Let's start saying that used properly, a knowledge graph provides a framework to extract inferential pathways connecting several objects, taking points of information and turning them into usable knowledge. A knowledge graph is a mathematical framework for dynamically gathering and semantically processing a large amount of structured and unstructured data and information representing multiple subject areas. By mining the sources of information, the platform creates an efficient algorithm-based representation of the overall knowledge it provides, allowing for capturing significant relationships, often hidden and semantically quantitatively across various complex data. Instead of basing results of individual elements, like a typical database query, it uses algorithms to construct relationships, the graph or network, amongst concepts that are not evident. It shows the relationships between concepts and their connections, derives inferences, and suggests promising areas of intelligence. As a result, a knowledge graph constructed from a large number of diverse information sources and dataset can be used to make predictions, support decision-making efforts, and identify strategies to find meaningful trends hidden within the information. A full-fledged knowledge graph can find correlation across essentially any type of dataset. Doing the kind of inferential work, it might take a full team of analysts with access to a very large amount of data that takes many hours to perform. Knowledge graphs require a flexible structure, a set of dynamic layers that define the set of types, properties, and relationships, continuously adjusting as new information comes through. While other graphs map a picture of predefined relationship between entities, those tend to be limited, as they can't easily account for the introduction of inferred data from other emerging relationships. Imagine, for example, the relationships that can be dynamically extracted when tracking business interaction between companies. If you have access to certain private database, you can have a supply chain link between any two companies. But such a relationship might not be enough. It is important to understand, on top of all the factual types of relationships that the two entities have in common, like sector or investor relationships or size and market or affiliation, that others can be inferred by second or third order connections. For example, if both entities are exposed to political, financial, or geographical risks, a link with such emerging relationship will enrich other existing ones. Moreover, there are relationships that form as an emerging properties of the graph itself. These are defined as emerging inferences. In other words, the amount of information that gravitates directly on or indirectly around any concept mapped into a graph generates an induced ontological, ever-changing layer that dramatically enriches the relationship between any entities of the graph. Knowledge graphs are also actual graphs based on mathematical models, which makes them easily expandable and scalable and allows for application of mathematical graph theory techniques and algorithms like network analysis. That ability to process and interpret plain language is at the cornerstone of what makes them unique. Finally, a knowledge graph is a living organism. Information keeps on coming through quasi real time, and knowledge graph change shape and form, so it's quite important to track the changes at any point in time.